All right, now it's time to focus on the quadrilaterals. Okay, we focused on all the polygons yesterday. Now it's time to turn our focus to all the quadrilaterals. So the first thing I wanted to do was introduce you to the whole family. Okay, so we have a family tree here of quadrilaterals. All of these quadrilaterals we will be studying. All right, and there's a reason, everyone see I broke them up into 3 sections. There's a reason they're broken up into 3 sections I'll go over at the end. But this is the entire quadrilateral family here. So we start with just the quadrilateral on top before we break it off. And there's only 2 properties you need for a quadrilateral. 2 properties you should know. One is how many sides? 4, and how many degrees in the quadrilateral? 360. That applies to all these figures up here. They all have 4 sides, and all their interior angles add up to 460. So the first family I want to introduce you to is the parallelogram family. All right, starting with Papa parallelogram here. All right, Papa parallelogram. As you notice, he has 3 children. The children of the parallelogram family, the first one. Guesses? Yes, Rosie the rectangle, yes. Why did I write Rosie? That's ridiculous. All right, there we go. Yep, laugh it up, laugh it up. There we go, that won't happen again. The second child, yep, Randy, the rhombus. And there's the golden child. Can't do any wrong. Yes, don't get weird on me. It's not like, you know, the rectangle and the rhombus all of a sudden square. All right, it's part of the whole family. All right, let's not get weird there. That the brother and sister there. All right, all of a sudden the square. No, they're all part of the parallelograms. Okay, can't go wrong. Can't go wrong. The square. Maybe some of you guys fit in that category. Now we have the second family. Now we have the second family, which is the trapezoids. We have Tony here. I'm not too sure what the relation is, but we have the souped up version of Tony, which is the isosceles, Isaac, the isosceles trapezoid. And then finally, we have the black sheep of the group. This is where many of you will relate to. All on its own, not a diamond, but a kite. Kyle the kite. All right. Okay, now, why do we have them broken up into 3 different groups? Here is why. Everybody in the parallelogram family has both pair of opposite sides. Everyone remember these symbols? Are parallel. Both pair are parallel. So all these figures here in the parallelogram family, the opposite sides are parallel. Versus the trapezoid, 1 pair. That's it, 1 pair. That's why they're separated. They only have 1 pair. And the poor kite, no pair parallel. Okay, so that is why we group them in these 3 groups. Okay, the first grouping has both pair of opposite sides parallel. Trapezoids only have 1 and kites have none. Okay? All good. All right, our focus for the next 3 days up until the quiz is just going to be on this bad boy right here. The parallelogram. Okay, is just going to be on the parallelogram, our focus, because there's a lot to talk about with that one. All right, so let's get right into it with the parallelogram. First thing, before we go over any properties, because we did not have to worry about this with a triangle, is how do I label it? Because if I said triangle ABC, you guys could put A, B, and C anywhere you want, wouldn't have mattered. It does matter now. Okay, it does matter now. If I call this parallelogram ABCD, where you put A, B, C, and D does matter. You can put A anywhere you want. You can start it anywhere you want. Okay, so you can put vertex A anywhere. But from here, you have to go clockwise or counterclockwise. You cannot jump diagonally. Okay, so wherever you put B has to be clockwise or counterclockwise from it. So you guys figure out how you want to go from there. And this is any quadrilateral. Any quadrilateral you have to label clockwise or counterclockwise. All right, let's find out what's so special about a parallelogram. I have 5 properties that are listed here. Unfortunately, though, some of you aren't going to like this. How should I put this nicely? Because you're a little lazy. All right, to be able to do these algebra and proofs, you got to know the 5 properties. Pretty cold. All right, got to know the 5 properties. You already know one. We labeled it on the family tree. Opposite sides are parallel. And remember our symbol for parallel. Please mark that on your diagram. As we get a property, let's mark it on the diagram. So the arrows represent parallel, not congruent. All right, here's your challenge. Period 1 could get 4 out of the next 3 out of the 4. Can period 2, or get all 4. And if you're wrong, you're wrong. Who cares? Aman, want to start us off with what you think one property of a parallelogram is? Not only are they parallel, they also are congruent. Opposite sides are congruent. Nice job. And let's go up back to our diagram. Let's mark some hash marks on here. Opposite sides are congruent. Perfect. All right. Got 1, 2 more to go. Matt, what do you think? Opposite angles are congruent. Meaning, angle D, for me anyway, might be different from you. Angle D and B are congruent, and so are A and C. All 4 are not congruent, just the opposite angles. That's a special type of parallelogram where all 4 are congruent. All right, can you get one more, or maybe both here? Hi, Logan. That's for any quadrilateral. These properties, and I'm glad you said that. I'm just letting everyone know. These properties we're writing down apply to just this family here. Okay, it just applies to that family. All right, so all of them have 360 and 4 sides. Ooh, can you do it? Or are you just going to bow and wave the white flag to period 1? Natalie, going to help your class out here. Give me a pair on mine. Give me a pair. Which ones you talking about? DNA or supplementary. You are correct. Yes. Here's why. Here's why. And I'll write the property in a second. Here's why. Remember back in our parallel line unit, these were called, are they inside or outside? Inside. Same side or alternate? Those are same side interior. Were they congruent or supplementary? Okay. All right. Now that applies. Here's what I'm going to call them though. I'm going to call them consecutive angles. Consecutive angles are supplementary. And again, consecutive, for me, A and D, D and C, C and B, B and A. Any 2 consecutive angles are supplementary. Nice job. Way to match them. Anybody want to try to get the 5th one? This is the toughest one. No, I don't think anybody's going to get it because I don't have them drawn in. You're just looking at this diagram here. Ready? No, no, stop, 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 stop. What did I just draw in? What did I just draw in? This is called a what? A diagonal. Let me draw in the second diagonal. Let me put these markings on the diagonal. What are they doing to each other? Diagonals bisect each other. That is the fifth and final one. All right. Now, again, before we go on and do some algebra problems with these properties, I got to stress these five, ready? These five only belong to this family. Okay? They do not apply to the trapezoids and kites. These five only apply to these guys. All right? But our focus right now is just on the old parallelogram. All right, you ready? Let's do this. All right. Solve for x. This is just basic applications of these properties. I'm going to call on somebody. I want you to set up the equation. And then when we solve for x, what property did you use? All right, so here we go. Let's start this journey with 14. What are you going to do to those two? 10 equals 2x minus 4. When you get the value of x, Maya, let me know. 7, yes. I don't have to plug it back in because it just says find x. All right, it says theorem, but I'm really looking for, Maya, what property did you use to set those two equal to each other? Here's what we're going to write, because this is what we're going to write tomorrow in the reasons column when we start proofs. What was this originally? I gave you it was a what? So that's how I'm going to start. Watch my new notation. I don't know if some of you guys are going to like this or not. What's an 11-ogram? That says parallel. Okay, parallelogram. If you just want to write the word parallelogram, that's fine too. Parallelogram implies, Maya, one more time, what property did I use? Diagonals bisect each other. All right, so let's start writing that in this way, because that's what's going to go in our reasons column. Nice job, Maya. All right, number 2, here we go. Find the value of x. Again, this is just basic stuff here. 8, what do you got for me? No equation here, I hope. X equals 16. Theorem used, we knew it was a parallelogram, and what property did we use? There you go, opposite sides congruent. Just want you guys to get in the habit of writing the theorem here. Any questions so far using these properties? Hopefully, are you starting to see, some of you lazies, that these are impossible if you don't know the properties? All right, impossible. I guess you could guess, but. All right, 3, set up an equation for me here. Solve for x. Oh, 19, what do you got for me? Go ahead, take your time, solve for x for me. Yeah, x equals 8. And then calm down so I can write. Yep, we use diagonals bisect each other again. Okay, nice job. Okay, 4x plus 3. Again, that, hey, just so you know, that's only pointing to this portion of the diagonal. That's it, not the whole diagonal. It's just 4x plus 3 is pointing to that portion of the diagonal. And IK is 35. $23, how about that equation? 2 times 4x plus 3 equals 35. Yep. I'll give you a second. Solve for x. It's going to be a little tough here. Kid doesn't have a calc out, but I know what the final answer will be. Can you get it without a calculator? Probably not. Okay. Prove me wrong there. Thank you. Thanks. Why'd you set up that equation, Dylan?
Parallelogram implies diagonals bisect each other.
Yep. There's not much we can do with the sides and the diagonals here, but yep. Not bad. Not bad for a rookie. Not bad. TI. Find TI. You don't have to give me a theorem here. Whew, thankfully. How do I find TI given those values? Think I can get a little help from 6, a little help from 6. So TI, what are you doing, Mike, again? 14, diagonals bisect each other, so RI is also 14. Value of TI, Michael? Okay, 28, yep. Okay. Everybody good? Okay, so that's about as much as we can do with the sides and the diagonals. Here's really where you got to buckle up, and that is for the angles. All right, I am going to do number 7 with you, and I'll let you do 6, 8, and 9 on your own. So I'm going to do number 7 with you. Okay, a couple things. You can start on any number angle you want. You don't have to go in order 1, 2, 3. Do you always have to use a parallelogram property? No, you don't. You can use triangles equal to 180. Vertical angles are congruent. Supplementary angles add to 180. Whatever gets the job done. And hey, maybe this. Find an angle that's not labeled that will get you to an angle that's labeled. Anything goes here. Just don't be one-track mind. I got to use all my parallelogram properties. Baloney. So I'm going to leave it open to you guys. You want to find 1, 2, or 3 first. Up to you. But be able to back yourself up. Be able to back yourself up. Yes, 23 again. What angle are you going for?
Angle 1.
Oh, right off the bat, angle 1. What do you got for me?
113.
Okay, prove yourself, Dylan. How did you know that was 113?
Parallelograms imply opposite angles.
One property of a parallelogram is that the opposite angles are congruent. True. Nice job, young buck. Here we go. 5. Angle 2. All right, I got you. What's angle 2? 45. How'd you get there? Oh, so you used angle 1 already, right? And 180 degrees in a triangle. Fine. Another way you could have gotten there, and I want you guys to make sure you always keep this at the top of your brain here. What do you know about the opposite sides? Not only are they congruent, but they're also parallel. Especially when I draw a diagonal in, what type of angles are formed? What type of angle was 2 in the 45 degrees? Yes, alternate interior, and what do we know about them? Congruent. All right, so when a diagonal or 2 are drawn in, look for those alternate interior. And then the only other thing I'm looking for is angle 3 here, which you could get multiple ways. 20? 22. I'll just ask, how'd you find it? Alternate interior with this 22 up here. Perfect. All right, all good. You can work with the people around you. I will write the answers to 6, 8, and 9 up on the board. Once you're good, you go on to the homework. If you're not good, you better call me over. All right? Any way to get the job done. Does not have to be a parallelogram property. Look back at the properties if you need to. If you see a diagonal drawn in, do I have any alternate interior? Vertical, supplementary, anything goes. Oh, wrong one.
Once you get pregnant, when your hairs are something.
Okay, hold on, Kevin, one sec.